Lesson 119, as you can see, and you guys are wondering about alien land, aren't you? Alien land. Okay, riddle from yesterday. Getting right to it for you guys. In alien land far away, half of 10 was 6. If that same proportion held true, then what would 1/6 of 30 be in this alien land? It was 6. I hope you guys were able to figure that out. If you and your parents could figure that out, do some more research, try to figure that out, or shoot me a private message in Google Classroom. All right, here we go. Okay. Riddle for tomorrow is to come a little bit later, so please pay attention. Okay, our lesson today is a fun one, okay, which you've already been taught because I like teaching stuff in advance because I get so excited about it, okay? But it's adding and subtracting fractions with different denominators, okay? So maybe it's a subtraction like 5/6 minus 1/2, or maybe it's a fraction problems like 1/4 plus 3/8. Okay, well, before we even start those, I'm going to show you a basic concept that if you don't know this yet and you don't remember it, you're going to have a hard time doing this, okay? So before we get into that, first let's look at these problems. If I have 1/2 equals blank eighths, question mark eighths, and I don't know what that is, how do I figure that out? Okay, remember, D down denominator, north, n numerator, okay, or n north numerator, okay. So whatever I do to the denominator, I have to do the numerator. So how do I get from 2 to 8? I go 2 times 4. So if I do 2 times 4 to get to 8, then I'm going to do 1 times 4 to get to 4. So 1/2 equals 4/8. Okay, now we're going to be using that concept, that idea, that computation process to be able to do today's problems, okay? Let's just try another one, just so we're ready. 5/6 equals question mark over 12, blank 12ths, okay? So how do I get from 6 to 12, okay? I go 6, math masters already know it, times 2, okay? Now whatever I do to the bottom, I do to the top, or vice versa. So 5 times 2 is 10. So 5/6 is the same as 10/12. Okay, you have to be able to do that. Now let's just say that the order of those were switched around. Okay, let's just say that it was, they gave us the 10/12 equals, and we knew there was that there, and we had question mark there. It's kind of a, okay, we had question mark there, okay, and laughing at my question mark, okay? I'm going to erase this lesson 119 just so it's kind of out of our way. And we can see our numbers a little bit easier, okay? So how do I get from 12 to 6? Well, remember we can inverse. We're driving towards multiplication. Inverse multiplication is division. Beep, division, beep, division. Okay, you got to look over your shoulder so you don't hit anything. Okay, so 12 divided by what is 6? 12 divided by 2 equals 6. So 10 divided by 2 equals 5. These problems are the same, okay? So you can think in terms of doing those both ways. Okay, the one you're going to be dealing with today, though, is not division. It's going to be dealing it with multiplication. Okay, so we're just going to jump right in, okay? Now, adding fractions, okay? So remember, to add fractions, 1/4 plus 2/4 equals 3/4. That was easy to remember because I'm going to erase this division one since that's not what we're doing today anyways, but I just wanted to remind you that that was possible with inverse operations, okay? Picture of that, okay? Okay, 1/4 plus 2/4, what does that equal? That equals 3/4. We can see a picture of that. Now that's possible to do because we have our denominators are the same, okay? So now if I think about that in a different way, okay, what if I had 1/4 plus 1/3, okay? 1/4 plus 1/3. How do I add those up? I don't have like pieces. They don't have common pieces that are the same, so I can't. Okay, so somehow I have to change one of those fractions, rename it, like we learned about. That's what we've been calling it, renaming one of those fractions to have the same denominator as the other. Okay, so I will show you how to do that after we do this problem here. Okay, so I'm going to turn the camera just a little bit. Remind me to turn it back when I go to the other side of the board. Okay, so we have, plain and simple, 1/4 plus 3/8. So we need to have common denominators, okay? Something that they both have in common. So I look at these two numbers, okay? And I think about the 4 and I think about the 8, okay? And this is where you guys did some work finding the least common multiples. And I said you could do 4, 8, 12, 16. You could do 8, 16, 24, 32, and you could just keep going on that, okay? And then you find the smallest one possible, okay? So we could find some that are in common, okay? The 16, they both have a 16, and they both have an 8, okay? The smallest, the least common is the 8. Now, that seems to take a little while, okay? So remember the trick that I gave you was you don't need to do the smallest one. All you need to do is the biggest one, okay? So do the 8, 16, 24, 32, okay? And you can keep going, okay? And sometimes as you get into this more next year, you're going to have to keep going to find common denominators, okay? So now what do? I just ask myself, does my 4 go into 8? Yes, it does, okay? So right away, 8 is my common denominator. So then I'm going to make 8 and 8, okay? Put an equal sign, and now suddenly I have a problem that looks just like my original problem over here, which was question mark, okay? And I have question mark, times what, times what, times what, times what. And to think about this, I actually have two problems there, okay? Just like I had two problems there. Kind of interesting, okay? So now 8 times what is 8? Well, whatever I do at the bottom, I do at the top. 8 times 1 is 8, so 3 times 1 is 3. Now, some of you guys are thinking, why did he take the time to do that? 3/8 stays 3/8, you're right, okay? But it's good just to get in the habits of doing the right procedures over and over and over again, repetition, okay? So now 4 times what is 8? 4 times 2 is 8. So whatever I do at the bottom, I do to the, say it with me, top, okay? So 2. So 1 times 2 is 2. Okay, so now I have renamed 1/4 to becoming 2/8. So this name is gone, okay? And I have renamed 3/8, to keep the same name, 3/8. Okay, so now I still have my plus sign here. I'm going to get rid of this. 2/8 plus 3/8 equals 5/8. And you got to check to see if this can be reduced, okay? Can 5/8 be reduced? Like thinking about what is reduced, okay? 6/8. Okay, can you take anything out of both of those? Yes, I can. I can take a 2 out. Okay, 6 divided by 2 equals 3. 8 divided by 2 equals 4. So 6/8 reduces to 3/4. Can I reduce 5/8? No, I can't. Okay, that is as low as it goes. That is my answer. Okay, so now I think about 1/4 and 1/3. When you see it written horizontally, switch it to vertical. I think it's easier. 1/4 plus 1/3. Okay, and you're going to get equals, you're going to plus sign over here, okay, and you're going to come up with a new denominator, okay, for each of those, okay. So take the big one. Does 3 go into 4? Nope. So what's the next multiple of 4? 8, okay. Okay, so this is where 4, 8, okay. Does 3 go into 8? Nope. So go to another one. 12. Okay, does 3 go into 12? Does 3 go into 12? Yes, it does. So 12 would be my LCM, okay? My least common denominator or my least common multiple, okay? So now suddenly I have a problem, okay? And I have a question mark here and a question mark here. looks just like these problems we started the day with. Okay, so 3 times 4 is 12. Whatever I do at the bottom, I do the top, times 4. Okay, so 1 times 4 is 4. 4 times what is 12? 4 times 3. Whatever I do at the bottom, I do to the top, times 3. So 1 times 3 is 3. And I have my plus sign. So these are renamed. Those names are gone. Okay, and I have 3 plus 4 is 7. Denominator stays the same as 12s. So 7 12s, can that be reduced? Is there anything I can divide out of 7 and 12 evenly? I can't, because 7 is a prime number, so we know right away. Okay, so 7 12s would be my answer there. Okay, now that works with addition, but it also works with subtraction. Okay, so number one most common mistake is kids having like 5 problems in a row, and it's add a fraction, and all of a sudden it says subtract a fraction. You just did 2 addings in a row, and then you just start getting in the groove, and you start going with it, and you just add these, okay? And if you add 5 6 and 1/2, you're going to get a different answer than 5 6 minus 1/2. So look at the process sign, add or subtract, to make sure you're doing the right thing. That's my big hint, okay? So you don't accidentally put the wrong answer. Okay, so now we have 5 6 minus 1/2. Okay, so do they have common denominators? No, they don't, so we need to make them, okay? So I start with my big one, the 6, and I say, can 2 go into 6? Okay, because that'd be like me getting the multiples of 6, okay? 6, 12, 18, okay? Does 2 go into 6? Oh, yeah, it does, okay? So suddenly, 6 is my new denominator, okay? Now, to figure that out, because some of you still are learning this, okay? 6 and 2, okay? Those are my denominators. So I get the multiples of them, okay? So 6, 12, 18, 24, and I can just get a few of them, okay? 2, 4, 6, 8, 10, okay? And now I gotta find the common multiples, but more specifically, the least common multiple, okay? So do they both have a 10? No. Do they both have an 8? No. Do they both have a 6? Yes, they both have a 6, okay? Now if I kept going, 12, yep, they both have a 12, and I kept going, 14, 16, 18, they both have an 18, and 20, 22, 24, they both have a 24. Okay, they got a lot of common multiples, but you want the lowest one, okay? Which in this case would be the 6, okay? So it's easier to say, does that denominator go into this denominator, the small denominator go into the big denominator? If it does, that's your lowest common denominator, or your lowest common multiple, okay? So now what do I have here? I got my question marks, okay? So these initial problems I started out with, okay? How do I solve that? How do I get from 2 to 8 times 4? So I do 1 times 4 is 4. Well, I'm doing that same thing right here. Okay, how do I get from 2 to 6? Times 3. How do I get, so what do I do the bottom, I do the top, times 3. So 1 times 3 is 3, okay? Now how do I get from 6, remember 5 6 isn't going to change names. 5 6 stays 5 6, okay? But just for the sake of staying in good routines, okay? 6 times 1 is 6. What do I do the bottom, I do the top? 5 times 1 is 5, okay? Now I have renamed these fractions, okay? Those names are gone and they have new names. And now I have 5 minus 3 is 2 sixths, okay? Now 2 sixths, if you left that as your answer, marked wrong. Why? Okay, because you can reduce it. Okay, can you divide anything out of the 2 and the 6? That are the same number evenly? Yes, you can. 2 divided by 2, 6 divided by 2 equals 1/3. Okay? So the answer is 1/3 there. Okay? So that's how you do that. Okay, I'm going to erase all this stuff. Okay, because that's the long way. And I want to show you one other thing here. Okay? Now let's say this is a subtraction problem, and you're getting in a hurry. Okay? And you just did an addition problem, solved it 5/8. You did another addition problem, solved it 7/12, okay? And you do this one, and you get your new denominators, and then you're just in the groove of adding 5 plus 3 is 8. sixths. Okay, and you get 8 sixths. Well, if that was your answer, okay, 8 sixths cannot be left alone. To remind you, there's 3 ways to write a division problem. 8 divided by 6, 8 divided by 6, and 8 divided by 6. 8 sixths. This is a division problem. So you would do 6 into 8. 6 goes into 8 one time. Okay. I'm going to move that over here. Okay. So 6 into 8, or 8 divided by 6. 6 goes in once. 6 times 1 is 6. Subtract 2. And then you read the clock for your fraction. 2, 6, 1 and 2 sixths. 2 sixths cannot be left alone. Okay, divide by, okay, which is divide by 2. So 2 divided by 2 equals 1. 6 divided by 2 equals 3. So you have your 1 and your 1/3. So this would equal 1 and 1/3 as your final answer. Okay? And that would be how you solve that problem. If it was an addition problem, that would be correct. However, since it was a subtraction problem, you did all that work, you have the right answer, you did all the math right, you still get it, okay, -1, okay, because you were supposed to subtract, okay? All right, that concludes today's lesson, okay, and you have 6 lesson practice problems to do on your own and check with your answer keys to make sure you fully understand it individually. And you are in for a treat because I didn't forget in my old age that you wanted to have another riddle. So here we are. If you multiply this number by any other number, the answer will always be the same. What number is this? If you multiply this number by any other number, the answer will always be the same. What is that number? Have fun with that lesson, guys, and we'll see you tomorrow.